So we're going to find the interval and radius of convergence of this Taylor series. So first thing we're going to need to do is find the first few terms. We're doing about 0, and so we need a few derivatives. G prime, just enough to see the pattern. G prime of x is 1 over 1 minus x times negative 1, because it is a chain rule. We might go ahead and rewrite that as negative 1 times 1 or minus x to the negative 1 to take our derivatives. Or you might recognize this and say, oh, well, we know the terms of this guy here. There's different ways of finding this series. This is just one of them. Now what's going to happen here, we got negative 1 times negative 1. It becomes a positive 1 times 1 minus x to the negative 2. But we got to multiply by a negative 1 because of the chain rule again. So then we end up with negative 1 minus x to the negative 2. Third derivative, we get 2 times 1 minus x to the negative 3, again times a negative 1. So that will give us negative 2 times 1 minus x to the negative 3. You might start to see a pattern here. We'll do this last one and then we'll see if we can have enough to put together our Taylor series. That'll be a positive 6, 1 minus x to the negative 4, but again times a negative 1. So all the terms are coming out negative. And if we look, we have 1, 2, 6, so 1 factorial, 2 factorial, 3 factorial. The next one will be 4 factorial because we're multiplying it in 4. They'll all be negative. So let's write out the first few terms. Now again, we're doing these at 0. G of 0 is actually 0 because of ln of 1. So that's not one of the terms we're going to be interested in here. G prime of 0 is 1. Excuse me, negative 1. G double prime of 0 is negative 1. G triple prime of 0 is negative 2. And G fourth derivative at 0 is negative 6. And you can imagine the fifth derivative at 0 will be negative 24, so on and so forth. Okay, so we have no constant term. So our first term is going to be negative x minus x squared over 2 factorial minus 2 times x cubed over 3 factorial minus 6 times x to the 4th over 4 factorial minus 24 times x to the 5th over 5 factorial. Now here's what's interesting. Notice that 2 could be written as 2 factorial. 6 we could write as 3 factorial. 24 we could write as 4 factorial. It really helps us see the canceling here, because what we end up with is negative x minus x over 2 minus x squared over 3 minus x to the 3rd over 4 excuse me, it's x squared, x cubed over 3, x to the 4th over 4 minus dot dot dot, and we start to see our summation notation. It's going to be x to the n over n, and we'll just start n at 1 up to infinity. So there is our closed form, and now we're ready for our ratio test. So the limit as n goes to infinity of a sub n plus 1, because we're doing absolute value, we don't need to worry about the negative. A sub n plus 1 will be x to the n plus 1 over n plus 1 times the reciprocal, so n over x to the n. We can see that these are going to cancel and go down to x, and we'll pull that out front. So we get the absolute value of x times the limit as n goes to infinity of, and we no longer need the absolute value, n over n plus 1. L'Hopital's one round of L'Hopital shows that this is 1 over 1, so that goes to 1. So this equals absolute value of x which we want less than 1, and there is our radius of convergence. But we also want to be able to find the interval of convergence. And again, I'm not going to worry about the negative because it's not going to determine the convergence or divergence. Let's just worry about this part here. And let's check our endpoints. So here's our check on the endpoints. If x is equal to -1, plugging that in there, I get this series of -1 to the n over n, which is an alternating series, and also the limit as n goes to infinity of 1 over n equals 0. So that one converges by the alternating series test. So we do want to include that endpoint. Do the same thing for 1. So we're going to check x equals 1. We plug in 1 in for n. 1 to the n over x, which is just 1 over x. That's our harmonic series. So that is going to be divergent, and we do not want to include that endpoint. So our radius of convergence is 1. Our interval of convergence is -1 to 1.